Hi, today me and Hannah will be teaching you Lesson 3-7, Graph and Critical Points of Polynomial Functions.
The objective in today's lesson is to learn how to find the derivative and the critical points of each function. This lesson will cover derivatives, which are used to find critical points of a polynomial function. Critical points are the point on a graph at which the graph changes direction.
Some important vocab you may need to know for this lesson is derivative, which is defined as this equation, a function, which is where one element of the domain matches up with exactly one element of the range, and a critical point, a point at which the nature of the graph changes direction.
Okay, so the first problem, we will be doing f of x equals 3x cubed minus 9x plus 5. To start solving this problem, you have to find the derivative. So you take the exponent and multiply it times the coefficient. So it would be 9x, and then you subtract the exponent by 1, so 9x squared minus, and this is obviously a 1, 9, and that is your derivative, and then you set it equal to 0, and you just solve. So it would be plus 9, so 9x squared equals 9, and then you would divide by 9, so x squared equals 1, and then square both sides, so x equals 1. That is one of your critical points. But then you have to take the derivative that you already found. So this one, over here. So that one. So after you find your first critical point, you take the derivative that you already found. So 9x squared minus 9, and you find the derivative of that. So you take the exponent again and multiply it by the coefficient, so 18x, you subtract this one, and then the 9 goes away, so you're just left with 18x equals 0. So then you divide by 18, and so of course you get x equals 0. So your critical points are x equals 0 and x equals plus or minus 1. So now that you found your x values, you have to take each x value and plug it back into your original equation. So we'll start with 0. So it would be 3 times 0 to the third minus 9 times 0 to the second to the first. So 9 times 0 plus 5. So it's 0 minus 0 plus 5. So then that one would just be 5. So your critical point there would be 0, 5. And then you plug positive 1 in. So it's 3 times 1 to the third minus 9 times 1 to the first plus 5. So 1 to the third is obviously 1 times 3 is 3. 1 times 1 to the first power is 1 times 9 is 9 plus 5. So 3 minus 9, negative 6 plus 5 equals negative 1. So your point there would be 1, negative 1. So then you just have to take negative 1 and plug that in. So I'll just go here. So 3 times negative 1 to the third minus 9 times negative 1 plus 5. So negative 1 to the third is just positive 1, so it would be 3 plus 9, because this will be negative times a negative plus 9 plus 5. So I'm pretty sure that's wrong actually. Okay, so then the last thing we have to do is plug negative 1 into our original problem. So 3 times negative 1 to the third minus 9 times negative 1 plus 5. So then negative 1 to the third is still negative 1, so negative 1 times 3 is negative 3, and then negative 1 times negative 9 would be positive 9 plus 5. So 9 plus 5 is 14, plus negative 3 would be 11. So the critical point would be a negative 1, 11. And then you're done.
Okay, so for problem number 2, we're going to find the critical points, the maximum, the minimum, and the point of inflection. So first, we have to start with the critical points. So you just find the derivative, again, like we did in the last problem. This marker's good. X squared minus 36x. And then you set it equal to 0 to find one of your x values. And then divide everything by 9 so you can get rid of that. So then it would be x squared minus 4x equals 0. And then to find more points, you can just take an x out of the equation. So it's x, and then x minus 4 equals 0. So then this one automatically just equals 0. So then you set x minus 4 equal to 0. So you just add 4, and you get x equals 4. So then you come back up here. And then you take the derivative of this equation. So minus 36. So you set that equal to 0. So, and then add 36, and then 18x equals 36, and then divide by 18, and x equals 2. So now you have all of your x values. So just like before, you just have to plug them back into the original equation. So let's start with 0 because it's the easiest. So 3 times 0 to the third minus 18 times 0 squared minus 4. So obviously, since we're multiplying both these by 0, they're both 0, minus 4. So this value ends up being negative 4. So this critical point would be 0, negative 4. And then we will take 2. So now we're going to plug our next x value in, which is 2. So 2 to the third is 8. So 3 times 8, which is 24, minus, and then 2 to the second is 4 times 18 is, so 18 times 4 is 72. So 24 minus 72 minus 4. That's negative 52. So then your critical point for that is 2, negative 52. So then the last point we have to plug in is 4. So I'll do that right here. So 3 times 4 to the third minus 18 times 4 to the second minus 4. So 4 to the third is 64, so 3 times 64 minus 18 times 16 minus 4. So 3 times 64 is 192 minus 18 times 16, which is 288 minus 4. So 192 minus 288 minus 4 equals negative 100. So your last critical point will be 4, negative 100.
Okay, so once you've found your critical points of your first derivative, you know that it will be either your maximum or your minimum. So then you graph your first original equation and you get something that looks like this. Judging by your points, you know that your maximum is the very top point at which your graph changes direction. So you know that 0, 4 is your max point. And you know that 4, negative 100 is the minimum point of your graph. Your point of inflection will always be determined from your second derivative's critical point. So 2, negative 52 is your point of inflection.
The third problem we were doing, we're going to find the critical points again. So first we're going to start with finding the derivative. So 2x minus 6, and then you set that equal to 0, and then 2x, well, add 6, and so then 2x equals 6, divide by 2, x equals 3, so that's your x value, and then you just plug it back in. So 3, okay, that doesn't give myself enough room. 3 squared minus 6 times 3 plus 1, so 9 minus 18 plus 1, so 9 minus 8 is negative 9 plus 1 equals negative 8. So your critical point would be 3, negative 8.
So once you have your critical point from your first derivative, you have to now determine if it's a maximum or a minimum. So you plug it into your graphing calculator, and then you look at your graph, and if the point falls to the bottom of the graph, then you know that it is your minimum point. Therefore, 3 and negative 8 are your minimum